Okay, Assalamu alaikum. Good evening. Okay, students. So we have been discussing linear motion part. In the last class, we studied about the conversion of the ST graph to VT and some more theory on linear motion. So in this class, I'm going to explain you some MCQs. Give you an idea about how to do past paper, and after that I will be sending a document which has more MCQs. So can you see this document? What do you see on the screen? Hello. What do you see now? CLR Jenny, what do you see this violation? Give me a second. Hello. Am I audible now? Clearly.
Yes, sir.
Okay. So can you see a past paper compilation book now?
Yes, sir.
So it shows this Pesuru book. I have prepared nice PDFs from that. So I will send these. If you have any other PDFs, you can use them too. But I will be discussing using this. Okay. And then it has only up to 2016. But I have added some more. Okay, I just put some pictures of the new questions. So now you have questions up to 2021. So you will do the rest of the questions and come to the next class. We will discuss those past paper MCQs. Okay. And after that, there will be a model exam. So sometimes I do exams for each subunit. For example, there will be linear motion exam. Sometimes if I don't have adequate number of questions, I will combine two subunits and do right. And then we will discuss those exams. Each subunit time. So classes per week. I will be faster than in the linear motion because the sections now, so we cannot take times like we did for linear motion. All right. Okay. So can you hear me? So start discussing. Lagging.
Excuse me, sir.
Hello.
Excuse me,
Yes.
sir. Can you repeat what you have said
Yes.
already?
Yes. What do you mean by what I have said already?
No,
Today's
you
class.
told no. You told about some exams in linear motion. I can't hear clearly.
Okay. I don't know what to do for this connectivity issue. I mean, Kenya, that's why. If I go to Colombo, it will be okay. So I will discuss the past paper MCQs today. Some of them, only some of them. And then the rest of the MCQs should be done by you all. Okay. After that, we will discuss those MCQs. You will be doing the PESUR MCQs. And after the discussion, there will be an exam. It can be for each subunit, or I will combine some of the subunits and do the exams. For example, there will be one exam for linear motion and the forces, equilibrium and forces and all. There will be one exam for Newton's law and all the related theory. There will be one exam for circular motion and rotational motion. Okay, like that we will be doing. So did you get that this time?
Yeah, sir.
Okay, so is my screen visible? Do you see a question on graphs, a 2015 question?
Yes, sir.
Okay, so I think the connectivity is fine now. So I will start discussing. Okay, yes. So let's read this question. So it says, if the velocity v of an object varies with time t as shown in the figure A. So the figure shows the variation of the velocity with time. So it's a VT graph. The corresponding variation of the displacement with time is best represented by. So what is your answer? Yeah, you can answer loudly. So we discussed about how to convert a ST graph into VT graph, right? But here they have given a VT graph and they ask you to convert that to ST graph. That is the question. So you should think like this. The VT graph is the gradient of the ST graph. Okay. So now look at the V and convert that to displacement. So now let's take it as segments. So I'm going to first discuss this part. Okay. So here, what happens to the velocity? Here there is a positive velocity. Okay. Positive velocity, which is a constant. So what will happen to the gradient of the ST graph? There will be a positive gradient, which is constant. All right. So there should be a straight line with an acute angle. So what are the graphs that are not possible here? Considering this part, obviously this won't come. Okay. This will not come because it doesn't show any graph here. This is possible. Yeah. This is possible. Yeah. This is also possible. Straight lines, acute angle with the x-axis. Okay. Then after that, what happens is the positive velocity decreases and it reaches 0. Okay. So how do you describe that for gradient? So you can say positive gradient decreases. Do you understand? So how will it look like in the ST graph? In which answer it's there? Misna, in which answer you see? Hello? Hello, can you hear me? Okay, in the first answer, right? If you speak, it's easier for me. I don't have to open the Zoom window. Otherwise, to check the chat box, I have to open. Okay, so in the first answer, it is shown beautifully, right? So you can see in the first answer, the positive gradient decreases and it becomes 0 at this point. Okay, whenever the graph is parallel to the x-axis, you call the gradient 0. You call it 0 gradient. Okay, then what happens? So you have already found the answer. The answer is the first one, because the other answers are not compatible with what we have discussed up to now. So with this, you have found the answer, but there is rest of the graph. So let's try to discuss that also, so that we can make sure that the first answer is the answer for sure. Okay. Yes. So then what happens in this segment? So in this part of the graph, there is a negative velocity increasing, right? So what should happen to the gradient? Negative, isn't it? So here, gradient decreases, right? This is like this, right? And then the negative gradient remains, the negative velocity gradient, which is obtuse angle, going to remain constant. So here you see a straight line, and the angle with the x-axis is also obtuse. So it is negative gradient constant. Okay. So the answer is the first one. And we have cross-checked it with the results. Did you get that?
Yes, sir.
Okay, good. Okay, the next one. So next one is two straight lines shown in the displacement time graph represent the motions of two objects A and B started from rest at time t is equal to 0. So they both started t is equal to 0. Moving along the positive x direction. So both of them move in the same direction. Which of the objects is true? Okay, you can make a lot of statements from this. Okay, but you have to find one correct answer. So instead of just going to the answers, shall we discuss about the motion? What do you think about these motions? What are the conclusions that you can come to while looking at this graph? Can each of you tell me one sentence each? I will start first. So I can tell the initial displacement of B is higher than that of A, because A starts from the origin. B starts from an initial displacement. So from the origin, it has already moved somewhere. Okay. So let's say, let's draw it in a diagram. So let's say if this is the origin, okay, O. So A starts here. Object A starts here. But B starts its motion from here. Okay. This is how they start the motion. And at the end of it, what happens? Both of them travel for a duration of t naught. And at the end of the motion, A reaches a higher displacement than B. So B remains somewhere here at this displacement, but the A has gone far from the origin. So the final displacement of A is higher than that of B. Okay, so that is one sentence that I am telling. Okay, it was a long sentence, by the way. Okay. What do you think about other? What are the other sentences you can tell? Just tell me something. Yeah.
A and B meet at a point.
Excellent. At this point, A and B meet. Okay. So actually, what do you mean by meeting? Meeting is when two people are in the same place at the same time. Okay. So here you can see at the same time, they both have same displacement, which means that they meet. All right. So at this point, which doesn't have a name in this question, if I say that this point is X, I can say at point X, both objects meet. Okay. What are the other things that you can say? What about the velocities? velocity will be given by the gradient. So both of them have positive velocities. If you take the angle, it is acute angle for both. So they have positive velocities. And in the question also, they say that they move in the positive x direction, so that you can say the velocity is positive. Which has the greater velocity? Harani? Which has the greater velocity? A has a greater velocity because you can see the angle that A makes with the positive x-axis is greater than the angle B makes. Okay, if you draw a positive x-axis and draw the angle for B, and let's say it's theta B, let's say the angle made by A is theta A, you can say that theta A is greater than theta B. So you can say tan theta A is also greater than tan theta B, which is the gradient. So A has higher velocity, but both of them have a uniform velocity. Their velocities are constant. Okay, the line is a straight line. So A has a greater constant velocity than B. They don't have an acceleration. For both of them, the acceleration is 0. So now we have made some sentences. So now we are going to look at the statements and see whether they are correct. So the first statement says that the object A has traveled for longer time than B. So what do you think? It's about time. Okay, very easy statement. We know both of them start at t is equal to 0 and finish their motion when t is equal to t naught. So the duration of motion will be equal. Okay, so the longer time story is wrong. So the first statement is wrong. The second statement says when time t is equal to t naught, object B has made a displacement greater than, what is this? I think it should be A. Greater than A. What do you think? What has the higher displacement? A, obviously. You can see it, point T naught. A has a higher displacement. Just look at the graph and decide that this statement is wrong. It doesn't need much thinking. Okay. And then third statement says A has a greater velocity than B. That is correct, like you said. So that is the answer we know. But let's check the other statements also. Statement 4 says object A has a greater acceleration than B. That is wrong. Both of them have equal accelerations. Fifth statement, both objects have same velocity at the point where two straight lines cross each other. They always had a constant velocity. Even at the point they are crossing, A is faster. It has the constant greater velocity. All right. So that statement is wrong. Okay. So the only third statement is correct. Okay. Okay. So let's move on to the next question. What about this? The graph shown in the figure represents the velocity time curve for an object. The corresponding displacement time curve is best represented by. So what is your answer? What's your answer? Guys, you should talk. What do you think, Aisha? What's the answer? Hello?
So is it second one?
Okay, so let's see. So initially, the positive displacement decreases. Sorry, not displacement. Positive velocity decreases and becomes 0. Right? So in the ST graph, the positive gradient should decrease and should become 0, which means flat. So positive displacement is seen in this graph and this graph. Others are wrong. This is 0 velocity. This is also 0 velocity. This one has a negative gradient, no? Obtuse angle. So here you see acute angle, acute angle, acute angle becoming 0 here. Here also it becomes 0. And after that, negative velocity increases, which means in displacement time graph, negative gradient will increase. Okay, the negative velocity increased, right? It is 0, and in the negative side, it is increasing. It's reaching higher negative velocities with the time. Okay, so that means that in the displacement time graph, the negative gradient should increase. So it should be the second one. Here you see positive gradient again. So this answer is wrong. Here you see acute angle. Let me draw that. At this point, it is 0. Here you see obtuse angle. So negative gradient. But here if you see, it's positive. Positive gradient would be like this. VT graph. Initially positive gradient decreasing and hitting 0, and then positive gradient again increasing. Okay, this should be the answer for this. I mean, if this was the question, third one will be the answer. But this one is the answer for this diagram. Okay, any doubts? Any questions? No. Okay, let's go to the next one. Okay, this is one interesting question. This is one interesting question. So here, my question is very simple. Identify the moments where the direction of the displacement, velocity, and acceleration change. That is a simple question that I'm asking you. You have to find out the times when displacement changes its direction, velocity changes its direction, acceleration changes its direction. What are the times? So first, let me explain displacement. That is very easy. I don't want to give you that question because that is like kind of humiliating you by giving that question. So I will answer that. Okay. So displacement, changing the direction. What is the meaning? What is mean by changing the direction? The positive becoming negative and negative becoming positive. That is what you mean by changing the direction. So at which point the displacement changes its direction? That is T2. It was positive all the time. At T2, from the positive side, the graph moves to the negative side. So which means T2 is the time when the displacement changes its direction. Now you should answer the question about velocity and acceleration. So let's focus on one thing first. So what about velocity? What are the moments where velocity changes its direction? Yeah.
T1 and T3.
T1 and T3. Yes. So can you all draw the displacement time, sorry, velocity time graph for this? Then it will be easy for you. Let me draw it here. Try to duplicate this again and remove this graph. Oops, sorry. Okay. I'm drawing the lines so that you can see the corresponding times. Okay, so initially from here to here up to T1, what happens? It is positive gradient, no? Acute angle decreases and becomes 0 at this point. So positive velocity will decrease and become 0. So you draw like this. All right. And then what happens at this point? Gradient becomes negative after this. So you see a obtuse angle. So it is negative gradient. What happens to the gradient? Huh? Is it decreasing? If it decreases, it will go more and more flat. It will become like this. If it is going like this, that means the gradient is increasing. Okay. So what kind of trend do you see there? It is increasing. Yes. So negative gradient increasing. So I can just extend the graph like this. Okay. After that, again, what happens? It will become flat, no? So negative gradient decreasing, and here it becomes 0, right? It becomes 0. If you recall my yesterday's explanation, it will be very clear for you. So it becomes 0. And then what happens? Here at this point, it becomes 0. And then here you see acute angle, no? It is increasing. If you see something like this, positive gradient increasing. So it will cross the line and go to the positive side. So now you see a graph like this. All right. So if I ask you the question that what are the moments in which the velocity changes its direction, your answer will be based on this graph. So you will say when the velocity goes to the positive to negative or negative to positive, that will be the moments where it changes the direction, right? That's what mean by direction. So here in T1, at T1, positive becomes negative. It goes to negative. So here it changes, and here it changes. The negative becomes positive. All right. So the answer for this one is going to be what? T1 and T3. All right. Okay. So what are you going to do for acceleration? Let's draw acceleration time graph also. Okay. So let me draw. Sorry, I forgot to change this S to V. It is VT graph. So now let me draw. You can try. Don't look at the screen. You can try your own answer and then check it with my answer. That will be more effective. So what about the acceleration time graph? Acceleration time graph will be what do you think? So acceleration will be given by the gradient of the VT graph, isn't it? So this segment has a constant gradient. What is it? Positive or negative? Hello? What is the angle that it makes? Huh?
Obtuse.
Yeah, so it should be negative, no? So negative constant gradient. Okay. And then after that, it is making acute angle, so it will be positive constant gradient. It's very simple, okay? What I want is your involvement. You have to just talk, okay? I think you have been spoon-fed for so long so that you have, like, people have actually forgotten the whole purpose of classes and teaching. The objective of the classes is your improvement. Okay. But students are like experts in copying the whiteboard and copying the screens, writing the notes told by the teacher, copying the method. Okay, the method is from you guys. Okay, so you have to answer, you have to leave mistakes. I told you, whenever you try a question, whether the answer is correct or wrong, you learn. Your brain is like that. If you get it correct, you have dopamine and your brain is happy, and then you learn. If you leave a mistake, it's kind of a scar in your mind, and you never forget the mistake you made. So always try to make mistakes, try to do things correctly. For both, you have to try, you have to talk, you have to try exams alone. I will be just sending the papers. You have to sit, allocate the time, you have to keep the timer, and when the bell rings, you have to stop writing. Okay, that kind of self-discipline is important when it comes to A-levels. It's always student-centered learning. Okay, so you have to put yourself in challenge, otherwise it's difficult. Okay, so speak up. So here you can see there is only one moment in which acceleration changes its velocity. Sorry, direction. I'm very sorry. Acceleration changes its direction here, no? Here. The negative acceleration becomes positive at the point T2. All right? So the answer for the acceleration part is T2. Okay. All right? So that is the answer for this question. This was a past paper question. Okay. In Tamil medium compilations, it was there because it is a 1986 or something question. So that it's not there in Pesuru book. It's only from 1992. I think, I don't know which year they introduced English medium for A-levels. Maybe it's from 1992. Before that, we don't have papers, I think. Do you guys have any knowledge about when they started English medium?
No, sir.
No, right? I think it's like 1992. I don't think they would have started very early, like medium. But I'm not sure about English medium. So let's try to do from 1992. But if I find any questions interesting, I will translate and give. Okay, I don't exactly translate the exact question. I will just give you the idea. Okay, that is possible. Okay, so last couple of questions. Okay, so it's about projectile motion because I couldn't teach you all the projectile motion. I'm going to teach you now. So projectile motion is a special kind of linear motion. It is not a circular motion. Okay, it is a linear motion. Why is it linear? Because even though it has a unique shape, so let's say like you throw a ball like this. Okay, you give a velocity in a direction which makes an angle theta with the horizontal. Okay, so now this velocity has two components. One component is the vertical component, the other component is horizontal component. Let's name the initial velocity as v. Okay, so the vertical component will be v sine theta. The horizontal component will be v cos theta. You should know how to take components. Okay, that is a basic maths. You should know. But anyway, if the angle theta is with horizontal, then you say the horizontal component is v cos theta, and the vertical component is v sine theta. Now, if you throw it like this, it will have a unique path. It will come like this. Okay, so the reason for that path is the change of these two velocities. Okay, let's consider the vertical motion. So in this vertical motion, always you will have the weight acting on it. So the weight of the object will act like this. So that mg force will produce a downward acceleration. If we use F is equal to ma in the downward direction, F will be mg equals to ma, A is equal to g. Okay, so this is your answer. Acceleration is g downwards. So due to the downwards acceleration, there will be deceleration in the upward motion because it is opposing the motion. Motion is in the upward direction. So this upward velocity will go on decreasing. So it will decrease, and it will become 0 here. Okay, these lines represent the magnitude of the velocity. So you can see the size of the lines is decreasing, which means the vertical velocity decreases. But the horizontal velocity will be constant. If you neglect the air drag, air resistance, we usually neglect that because if we take that into account, we can't discuss the physics theories. So we neglect that. So if you neglect the air resistance, there is no resultant force in the horizontal direction. So in the horizontal direction, the velocity will be constant. Even when it reaches the topmost point, okay, the highest point, it will be v cos theta horizontally. There will not be any vertical velocity there. V is equal to 0 vertically. All right. But when it starts the last half of the motion, again, it will start to gain a vertical velocity. Why is that? Huh? Why is that, kids?
Gravitation acceleration increases.
Yes, there will be gravitational acceleration. We have already found out the downward acceleration of this object. So that gravitational acceleration will increase its velocity. So gradually, it will gain the velocity, and finally, when it reaches the ground, it will have the same velocity as it started. Okay, the horizontal will always be there. No? Horizontal will be there. So the final resultant velocity, or you can say speed because the direction is different. The final resultant speed is equal to the initial speed it was thrown. Okay, so that is what you see in a projectile motion. So in a projectile motion, there are two motions. One is the horizontal motion, which is constant. The other one is a vertical motion, which is under gravity. So if you are drawing a VT graph, sorry, two VT graphs for the horizontal and vertical motions, how will you draw? So let's say this is horizontal. Let me draw a graph for vertical also. Oops, sorry. Why it duplicated this also? Okay. Okay, and vertical velocity. So horizontal will be a constant, and you take it as a positive direction, it will be always positive. So it's like this. Vertical, it will be like a motion under gravity. So vertical velocity decreases, it becomes 0, and in the opposite direction it increases and again reaches the initial vertical velocity. So it will be like this. The positive direction, it decreases, and finally it becomes 0, and in the negative direction it says, okay, this is a traditional question. They know that you can answer, and they know that we know they will put such a question, but they still put because they all love you. They want to give you marks freely. Okay, so don't make mistakes in such questions. These are very easy. Okay, so what is the answer for this? They just ask you the variation of horizontal and vertical components of the velocity with time. What's the answer? It's very simple. Come on. It's fifth answer. Okay. Why do you make me tell the answer? Yeah. I mean, I don't know. When you put the second answer, maybe for this one. It cannot be right. What is the answer? It's fifth answer, right? Fifth answer. Because I have already explained you everything about that. Now you have to just pick the answer. Okay, all right. So let's go to this one. This is again combination of projectile motion and relative velocity. Okay, so
Excuse me, sir.
yes, yeah.
In the last question, can't we draw that why we like that vertical one in the same direction, in the same positive part?
Why it changes, right? Obviously, up to this point it's upwards. Once it reaches 0, then it changes the direction. So it should go to the minus. If they ask about the speed, you will draw like this, because speed is a scalar, but velocity is a vector. So you should clearly show that it changes its direction of velocity. Did you get that?
Yeah, sir.
Okay. Okay. So it should go to the negative side. Okay. So let's read this one. A person A standing on a trolley, moving with a constant speed V on a straight horizontal track, drops an object as shown in the figure. B is not observer standing on the ground. What do they say? I think B is an observer standing on the ground. Okay. Unnecessary. Am I right? He is just standing on the ground, right? He is an observer standing on the ground. If the air resistance is negligible, the paths of the objects as observed by A and B are represented by. What is your answer? Yeah. Hello.
Could it be third one?
Why should it come this way? So just think about it. So as the person A is dropping the ball, velocity, because it was already in a moving system. So as the system moves, every object in that system will have the velocity of the system. So like the trolley, this boy and the ball he is holding will have the velocity V in this direction relative to Earth. So this guy is on the Earth. So this guy will observe everything relative to Earth. So let's take B. So B will observe a horizontal velocity for the ball in this direction. And when the ball is dropped, the ball will start to accelerate under the gravity downwards. Right? That is not preventable. The velocity, gravitational acceleration is always there. So it will pull it definitely downwards. So B will see a projectile motion, a constant horizontal velocity, and that sounds like a projectile motion, right? It is a projectile motion. So it will move like this. This will be the path as observed by B, because that guy will observe this thing relative to Earth. What about A? What will A see? What will A observe? So now we have to describe the motion of the ball relative to A. So you can see the A is on the trolley. So A will have the velocity V of the trolley. Okay. So A is moving with the velocity V. Ball also has a velocity in this direction, V, and it will anyway accelerate downwards due to the gravity. Okay. All right. So will A observe this velocity V horizontally? He will not, right? Let's say that you are relative to you. Let's say you are sitting where? Inside the bus. And will you have a
So your voice is lagging.
in the bus driver or the person who you, any person? You will not, because you all have the same. So when you have a velocity, my voice is lagging.